Hi there, and you're watching Gley soil formation with Mr. Mercer on Geography Geeks. Now, in this question, you'll be asked to describe and explain the conditions under which a soil like this forms, or to describe its main features. You might be asked to use a diagram, in which case I would recommend a ladder structure diagram, and I'll show you how that's built. Alternatively, they may provide you with a diagram, in which case you need to talk in slightly more detail and in a paragraph. Okay, so let's get started. The first thing to know how to do is to label each layer, and that goes AO layer, A horizon, B horizon, and C horizon. Now, with a Gley soil, I want you to imagine a moorland environment, quite boggy, quite wet underfoot, cold temperatures, very high precipitation. Now, those conditions lead to slow decomposition within the AO layer. And so quite a thin layer of dense, acidic, pH 3.5 more humus forms. The plant life in the AO layer, as a case study example, you could use the term Juncus effusus, and that's a plant that grows in the AO layer. Now, the high levels of precipitation, of course, cause waterlogging in the soil. This leads to anaerobic conditions, and again, slow decomposition. So the A horizon and the AO layer are going to be very dense with unbroken down vegetable matter, which hasn't decomposed. And that can lead to peat forming, which is the A horizon of this soil. When you cut it up and dry it out, it's so dense with undecomposed matter that it actually works as a very efficient fuel. The low biota in the anaerobic waterlogged soils will mean that the horizons are very clearly defined, as you can see in the photo. Now, in the B horizon, you have a more blue-grey colour, and this is due to the iron compounds that are within this soil being reduced chemically from their usual red colour. Now, when the soil dries out in the summer, those concentrations of those ferrous compounds, the iron, within the soil that has been bleached this blue-grey colour, are allowed to reoxygenate, and that allows them to turn back into a rust colour, and that takes the form of a kind of rust-coloured mottling effect within the B horizon. That process is known as glaying. Finally, you've got the weathered parent material at the bottom, and that will often be impermeable, thus not supporting drainage and encouraging the waterlogged nature of the soil. The roots of the Juncus effusus don't reach very deep, so they're not going to return nutrients to the AO layer very efficiently, but there will be heavy leaching within this soil. Okay, I hope that helped. Just to summarise, you've got the zone of alluviation, and that's leaching all the nutrients that are forming in the AO and A horizons down into the B horizon. That downward leaching, combined with glaying, causes the red mottling of ferrous compounds within the B horizon. And that's when those iron nutrients that are washed down reoxygenate in the summer thaw or in summer melt when it dries up a bit. And then finally that takes you to the zone of eluviation and on into the C horizon. Okay, I hope you got something from that. If you've got any questions, come and find me in class or at a revision lesson.